Hello everyone. My name is Mantasha and I am a second year BSc Zoology Honours student from Hansraj College. In today's video, I will be presenting and explaining the topic climate resilient crops. Let's begin with a simple situation. Imagine a farmer who has just sown his crops, full of hope for good harvest. But here's the reality. Nature is unpredictable. In one case, there is no rainfall for a long time, and soil dries up, cracks appear, and crops weaken. This is drought. In another case, there is excessive rainfall, fields get flooded, and crops remain submerged and gets damaged. Different situations, same result crop failure. And this is exactly where climate resilient crops come in. These are specially developed crops that can adapt to changing environmental conditions and still produce yield, performing better than normal varieties under stress. They don't just handle drought and floods, but also heat stress, where plants wilt due to high temperature, and salinity, where salt in soil makes growth difficult. So, overall, these crops are designed to survive harsh conditions and still ensure food production. Now, the real question is, why do we actually need them? Look around us. The climate is no longer stable. Temperatures are rising, rainfall is unpredictable, and extreme weather is more frequent. You don't even know when stepping outside whether it's going to rain or not. One season brings drought, the next brings flood. Because of this, crop growth is becoming difficult and unstable. And unstable conditions always lead to consequences. First, frequent crop failure. Months of effort can be lost in a single event. Second, food shortages, since crop failure directly affects food supply. Third, economic losses for farmers whose livelihood depends on harvest. But here's the key idea. Every problem points to a solution. If crop fails, we need stable yields. If food is scarce, we need food security. And if farmers face losses, we need risk-resistant crops. And that is exactly what these crops are designed to do. Let's look at how they are developed. Scientists don't create traits from scratch. They identify useful traits already present in nature, like drought or heat tolerance, and introduce them into crops. This is done through different techniques, some traditional like conventional breeding and hybridization, and some advanced like mutation breeding, genetic engineering, and CRISPR. Let's quickly understand each one of these. Conventional breeding involves selecting naturally strong plants and growing them over generations to strengthen the traits. It's simple but slow and depends on natural variation. Then, hybridization. It means crossing two plants to combine traits like high yield and stress resistance, resulting in improved crops. A common example is hibiscus, where varieties are crossbred for better traits. Then, mutation breeding creates genetic changes using radiation or chemicals. These are useful mutations and are selected and developed further. Then comes genetic engineering. It directly modifies plant genes by introducing special traits like drought or pest resistance. These are also known as the genetically modified crops. And then comes CRISPR. Clustered regularly interspaced short palindromic repeats. It is a modern gene editing tool. It works like molecular scissors, allowing precise and faster genetic changes. Now let's move to real life case studies from India. We begin with following examples. The sub-1 rice variety, which can survive floods by remaining submerged for nearly 2 weeks and still recovering. This is highly useful in flood-prone regions like eastern India. Next is Sabhagi Dhan. It is a drought-tolerant rice variety that grows with minimal water and matures early, ideal for dry regions like Jharkhand and Chhattisgarh. Beyond rice, heat-tolerant wheat varieties help maintain yield even during rising temperatures and heat waves. And finally, millets, Shri Anna, naturally resilient crops that need very little water and grow even in poor soils. These examples show how Indian agriculture is adapting using both science and traditional crops. Looking beyond India, globally many important developments have also taken place. For starters, food-tolerant rice sub-1 developed by IRRI in the Philippines survives long submergence. Drought-tolerant maize developed by CIMMYT performs well under low rainfall, especially in Africa. Then comes salt tolerant wheat and rice, developed by ICBA, which grow in saline soils. Last but not the least, climate smart wheat, which can tolerate both heat and drought stress. These efforts show that this is a global response to a global problem. Now let's understand what all of this work has achieved in real terms. The development of climate resilient crops has significantly improved agriculture under changing and unpredictable climate conditions. One of the key achievements is the increase in crop productivity even under stress conditions like drought, floods, heat waves, and salinity. These crops can now survive harsh conditions and still maintain stable yields. Another important success is the development of stress tolerant crop varieties such as flood and salinity resistant crops, which were not widely available earlier. This has also greatly improved food security, especially in climate affected regions, while also reducing losses for farmers. On a global level, climate resilient agriculture has gained strong recognition and is now part of major initiatives like the UN Sustainable Development Goals. Organizations such as FAO, IRRI, CIMMYT, ICAR, and ICBA are actively contributing, showing that this is now a global priority. However, there are still challenges. Developing these crops takes years of research and testing. Then the cost of development is high due to advanced technologies. And the traits like drought and heat tolerance are complex and controlled by multiple genes. Then comes the access to biotechnology, which is limited in many developing regions. And every variety needs testing across different environments. So while progress is strong, there is still work to be done. Now to conclude, climate resilient crops are one of the most important developments in modern agriculture. As we have seen, climate change is no longer something distant. It is already affecting us through unpredictable rainfall, rising temperatures, droughts, floods, and many other extreme conditions, all of which directly impact crop growth and productivity. To deal with these challenges, scientists have developed different approaches that we discussed. And these methods are now helping in developing crops that can actually survive harsh environmental conditions while still maintaining stable yields. We also went through several examples from India as well as international research efforts, and they clearly show that this is not just a theory anymore. Climate resilient crops are already making a real difference in agriculture and in farmers' life. At the same time, we also understood that there are still challenges like cost, time, and technological limitations that need to be worked on. So, in the end, climate resilient crops are not just an option for the future, they are becoming a necessity for ensuring sustainable agriculture and global food security in a changing climate.